Hello. So this second video is a look at, basically it looks at a question. The question is, why doesn't the nucleus explode? Well, why might the nucleus explode? We know from Coulomb's law, which we derived in the previous video, the force between charged particles is a constant, call it 1 over 4 pi epsilon 0, multiplied by the product of charges over the square of the reciprocal distance between them. We know this is Coulomb's law. Okay, so we can say that the force, let's just call this a constant, and we'll change the equal sign to a proportional sign. So we're incorporating the constant in here. The square of the charge over the reciprocal distance between them. So let's say we have a positive charge and a positive charge, the separation r. Then here, the force between two like charges would be positive because Q is +1 and the other Q is also +1. So it's going to be +1 multiplied by +1 over the separation r squared. So this is 1 over r squared. Importantly, we have a positive force. Positive forces are repulsive. Okay. However, if we had a positive and a negative charge, so let's say we had a negative charge here, then the force here would be proportional to a plus charge and a negative charge over r squared. So this is going to be negative 1 over r squared. So we have a negative force when we have an attractive force. So a negative force is attractive. So the saying opposite charges attract, they attract because they have negative forces. Like charges repel, they repel because they have the same positive forces, same charge, positive forces. Okay, so this is a recap on Coulomb's law. So let's erase that real quick. Okay, so we can say that the force, I'm going to call this force electrostatic. So when I say force electrostatic, I'm talking about the force based on Coulomb's law. We said that that was equal to 1 over 4 pi epsilon 0 q squared over r squared. Now I'm going to take all of this just to make the following argument a bit more succinct and clear. I'm going to call all of this K. Why K? Just because it's a constant. Okay. So we've got the electrostatic force equals K over R squared. It just allows our discussion to be a bit more simple. Now, Coulomb's law does not operate inside the nucleus. The nucleus is much more complex. Okay. But a law similar to Coulomb's law we can think of as operating inside the nucleus. So let's call the force operating inside the nucleus F sub n. And this is similarly equal to a constant. Let's call this constant A. Why A? Why not? However, this constant, and it's also a constant over r squared, but there's a decay variable here as well. So it decays exponentially. Okay, according to this expression here. So the constant here doesn't decay, it's just constant over r squared. Here the constant over r squared decays exponentially as minus r over r0, where r is the distance between particles within the nucleus. Now, r0 is roughly, well, we're going to assume it's the diameter of the nucleus. And it's approximately equal to 10 to the negative 15 meter. So the nuclear force operates only within the confines of the nucleus. Okay, for reasons that we definitely don't have to discuss. So we're looking at the ratio of the nuclear force to the electrostatic force. Okay. Well, this is equal to this constant A, e to the minus r over r0 over r, and then Fe K over r squared. And all 0. So what does this mean? This means when you're looking at separations between protons, for example, when the proton separation is a lot less than the diameter of the nucleus, then this decay becomes 1. This decay then just multiplies A, so we just have A over K. So Fn over Fe equals A over K. Now A, the constant from the nuclear force, let's say is about 1. K, the constant from Coulomb's law, is about 1 over 137. So we can see that A is a lot larger than K. What does this mean? This means that F, the force in the nucleus, is a lot greater than the force due to Coulomb's law when you're inside the nucleus. So inside the nuclear force wins. It's able to overcome the Coulombic repulsion between the positively charged protons. Recall in the video we saw that like charges repel, so the positively charged protons should repel each other. They do, compensated by this much nuclear attractive force. In short, this explains why the nucleus is stable and does not explode.